Alright, so now we're going to talk about how you would find the LCD of two rational expressions where they don't already have a common denominator. So to find the LCD, right? The least common denominator, the lowest common denominator. Here's what you do. Step one, you want to factor each denominator completely. Alright, so step one is to factor each denominator completely. What you don't want to do is you don't want to factor the numerators, you only want to factor the denominators. Now, this little note I'm going to write here in the parentheses is important. If a factor repeats itself in the same denominator, so you're factoring one denominator, but that factor repeats, you want to write it as a factor raised to an exponent. So, for example, if I was to say I factored and I ended up with like x plus 3 times x plus 3, you really don't want to leave it like that. You really want to write this as x plus 3, the quantity squared, right? So x plus 3 to the second power. So if something I got factored to that, I'd want to write it as that factor to that power. And it's going to become important as we move forward. All right, the second step is you want to list all factors that appear in any of the denominators. When the same factor appears in more than one denominator, write the highest power of that factor that appears. All right, so you may want to pause it here to write this down. So what you want to consider here is that, okay, I'm factoring all my denominators completely. And then I'm going to list any factors that show up in either of my denominators. Now, if any of those factors, shows up in both of my denominators, I want the factor that has the highest power. So, for example, if I had x plus 3 and I had x plus 3 squared in a different denominator, I would choose the x plus 3 squared, the highest power I see of it. You don't combine the powers, is the main thing to watch out for. You want just the highest one that appears. And then, step 3, if you list these properly, then you already have it. The LCD is the product of the factors found in, I'll say 2, right, in step 2. So if you've listed all these factors next to each other, the LCD will be that product, right? So product meaning multiplication. So you want all the factors present in your least common denominator or your lowest common denominator. And that's how it really worked for, regular fractions when we just had, integer denominators. But now we want to look at it in terms of, these are going to be expressions. So you may want to pause this to write this down. Otherwise, we're going to move to the first example, just finding the LCD. So for this example, if I said Find the LCD. Alright, so make sure you're paying attention to the directions. So the directions don't say add or subtract, so make sure you're doing what it says to do. For this first one, if I said I had 2 over x minus 2 times x plus 5 plus 4y over x plus 6 times x plus 5. Remember what I'm doing, I'm looking for the LCD. So the least common denominator, lowest common denominator, the first thing you wanted to do was factor each denominator completely. Well, they already did it for us, which is nice because now we don't have to worry about it. If these weren't already factored in the denominator, you want to factor it. The numerator doesn't matter. And now when I'm looking at this, what did we say for step 2? Step 2 said list all factors that appear in any of the denominator, right? And you want the highest power of that you see. So we have a factor of x minus 2 here. We don't have any x minus 2's here, but you want any factors that show up in either of them. So I need x minus 2. And then I have x plus 5 here. I also have x plus 5 here. But the factor that I'm looking at is x plus 5. What's the highest power of it that you see? Well, it's just to the first power. So this is just x plus 5 to the first power. So just x plus 5. You don't want to say squared. Sometimes people make that mistake. It's not how many x plus 5's you see. It's the highest power of x plus 5 that you see, which is only to the first power. If you try to put squared on here, now you won't have a lowest or you won't have a least common denominator. You don't want to do that. Right? This is a factor that appears in both of them. So we just need it once because the highest power we see of it is just once. And then in this one we have a factor of x plus 6. We don't have it in the first fraction, but that's okay. We still need it. Any factor that appears in any denominator, and that's to the first power. It's the highest power of it we see, and then we already took care of x plus 5. So the LCD is x minus 2 times x plus 5 times x plus 6. The order of these does not matter. Multiplication is commutative, can be done in any order, but you do need all 3 factors present there. All right. The way we're going to use this later on, and we kind of alluded to it in an earlier video, is that we're going to, try to multiply these denominators by what's missing to make this the LCD, and then whatever you do here, you'll do to the top to get the equivalent form. Let's take a look at another one. If I said I had 3 over x minus 2 times x plus 4 quantity squared minus 5x plus 2 over x plus 4 times x minus 1. So again, I'm not adding or subtracting yet. I'm just trying to find the LCD, right? That's what directions say to do. To find the LCD, first thing you want to do is factor your numerators or factor your denominators completely. Factoring your denominators completely, these are already factored, which is good. Because it's helpful, because then you don't have to do it yourself. If you had to factor this yourself, make sure you do. So here, the first factor I see is x minus 2. I don't have any factors x minus 2 here, but all it has to do is appear in one of them to be used as part of our LCD. So we need x minus 2 to the first power. Here I see a factor of x plus 4 quantity squared. Here I just have x plus 4. So I know I need a factor of x plus 4. Now remember what my step 2 said earlier. I want the highest power of x plus 4 that I see. This is to the first power, this is to the second power. The highest power I see is the second power. Be careful, don't say third, right? You don't combine these. It's whichever is the highest power you see. So x plus 4 to the second power is the highest one I see. That's why it's important to write a repeated factor. Because this would have been x plus 4 times x plus 4 is that factor to the power. So x plus 4 to the second power. And then I have x plus 4 already for that factor we just talked about. And then x minus 1, well, as long as it appears in either fraction, we need the x minus 1. That's to the first power because we don't have any higher powers of it there. And so then your LCD is x minus 2 times x plus 4 squared times x minus 1. Keeping in mind that you're going to vary on the order of this, probably from other students and from what you might see in solutions, but the multiplication can be done in any order, so it's okay to write it in that order. Let's take a look at this one. If I said 7 over 4x minus 2 over 5x to the third. Now, first off, we would want to factor the denominators completely to find the LCD. The these are monomials, so they're single terms. We don't have any factoring to do there. So we're ready to find our LCD right away. For the coefficients for 4 and 5, you really want the smallest number that 4 and 5 are both factors over. The smallest number that 4 and 5 both go into evenly is another way of saying that. So smallest number that 4 and 5 are both factors of, well, that's 20. And you should know that. And then for the variables x and x to the third, these are like their own factors. So I have x, that's a factor. What power do I need on it? Well, the highest power I see is x to the third. And the reason that we do this, just so you have an idea of how we're coming up with it, is that what I really want to do is be able to make these both look like whatever the LCD is. So you always want the higher power that you see, because you can always multiply the smaller one by something to get to the higher power. You can't multiply the higher power, though, by something to get to the smaller power, at least not something that's easy to work with. So that's why we always want the highest power you see will give you the smallest one that they both can go into evenly. That's why it's the least common denominator, but you're using the higher power of your factor. And we'll talk about that more when we do some more adding problems and subtracting. How about this one here? If I said I had 4 over x plus 7 plus 8y over x. So first off, least common denominator, you need to factor each denominator completely. These denominators are both factored completely. We don't worry about the numerator here. And then I'm looking for the LCD. Now be careful here when you're looking at the LCD. So you have a factor of x plus 7 here and a factor of x. The common mistake people make here is they just say the LCD is x plus 7. But you can't use x plus 7 because you can't multiply x by something to get to x plus 7. Right? You're adding 7 to it, but you have to be able to multiply one to get to the other. So, x plus 7 is its own factor, and x is its own factor. Just like if these were in the numerator and denominator of a fraction, you wouldn't be able to cancel them out. Right? That x is married to that 7 by that plus sign. This x here is really like x plus 0. They're not the same factor. So if I'm looking for this LCD, I need both of these to appear, x plus 7 and x, because they're different factors. They're both to the first power, so really I'll write this as x times x plus 7, right? You need the factor of x showing. You also need the factor of x plus 7 showing. You can't just use x plus 7, because x doesn't multiply by something to get you x plus 7. And vice versa. You can't just use x, because you can't multiply x plus 7 by something to get to x. Right? So you need both of these factors in this case, because they are different factors. That's really the key thing. And we'll look at just one more here. If I said I had 5 over 4x squared minus 12x minus 7x over x squared minus 6x plus 9. So remember, the directions are just find the LCD. So if I'm trying to find the LCD here, first thing I need to do is factor the denominators completely. In the previous ones I showed you they were factored, in this one it's not, so we need to factor this one down. So let's factor this GCF out of here. 4 and 12 have a common factor of 4, x squared and x have a common factor of x. So we're factoring out 4x. Factoring out 4x from the 4x squared just leaves me with x. Negative 12x factoring out the 4x gives me negative 3. So this factors really to 4x times x minus 3. The x squared minus 6x plus 9, well, there's no GCF. We have 3 terms. I don't see a value in front of the x squared. So 2 sets of parentheses. We need x times x in front. And then multiplies to a 9, adds to a negative 6. So that would be negative 3 times negative 3, right? Because negative 3 times negative 3 gives you a positive 9. Negative 3 plus negative 3 gives you a negative 6. And then remember, if this factor, x minus 3 times x minus 3 repeats itself, you really want to write it as x minus 3, the quantity squared. So you're really looking at, this last one here when you're comparing these. So let's now write the least common denominator, the LCD. So we need every factor that appears in either denominator to show here. So the first factor I see here is 4. I don't see any coefficient in front of this. So you need the 4 because it shows up in one of them, right? This really, the coefficient here is 1. The smallest number 4 and 1 can both go into, or the smallest number 4 and 1 are both factors of, would be 4. So you need the 4 as a coefficient. Don't leave that out. Here I have a factor of a single x. Here I don't have any, but as long as it shows up in 1, I need it. So I need the 4 and the x. And then here I have a factor of x minus 3. I also have a factor of x minus 3 here. The highest power of x minus 3 that we see is x minus 3 squared. So you want the highest power you see is the second power. Don't combine them, right? It's the highest one you see from either of your fractions. And so the LCD will be 4x times x minus 3, the quantity squared there. When you do that, you know, what's going to happen when we go into the next section, so this is the end of this section, but when we go in the next section, you know, if we wanted to find a common denominator here, what I really would do is I'd look at these last parts and I'd say to myself, okay, well, what do I need to make this denominator look like the LCD? Well, I'm missing a factor of x minus 3, so what I would do is I'd multiply the denominator by x minus 3 to make it look like x minus 3 squared, but if I do it down in the denominator, I have to do it in the numerator. Similar, in this fraction, I say I have x minus 3 squared. I want it to look like 4x times x minus 3 squared, so I'd be missing a 4x, so I'd have to multiply the denominator by 4x. If I do it in the denominator, I'd also have to do it in the numerator. And then that will give you two fractions that have the same denominator, and then you'll be able to combine like terms. So hopefully this helps in understanding how to find the LCD for rational expressions. And then in the next section, we'll talk about how you actually go through the adding and subtracting. It really combines what we did at the beginning of this section along with this LCD information.